All right, hello everybody. Welcome to Full Momentum and HEC-RAS Vodcast. My name is Ben Cary, and here as always with me today is Chris Goodell. Chris, welcome to episode 6.
Thanks, Ben. How are you doing? Good to see you again.
I'm doing good, man. The weather's turned a little bit around the Pacific Northwest. It's a little rainy, which is unfortunate, but that has given me the opportunity to try a few new beers that I hadn't tried before, and so I'm enjoying that part of it.
I hear you. I hear you. So, of course, right now things are closed down, so we haven't really been able to go out to our favorite brew pubs lately. What are you missing out? What's your favorite go-to? What's the go-to spot for Ben Cary
It's a great
when he's
question.
looking for a really good craft brew?
There's so many good choices in the Portland area. You know as well as I do, we're very spoiled to be in the region where we are from a beer standpoint. But my favorite brewery to both go to and especially to bring folks that are out of town is a brewery that has 3 locations now in the Portland area called Great Notion. They make awesome beer, and I think the coolest thing about it is they're one of the most unique breweries. Every beer they make is very, very unique. It's extremely fruit heavy, and so it's a really great beer to bring folks that aren't super excited or super into like the hoppy hophead type of beers. It's fun for everybody. They make a lot of really, really cool flavors. They have great food. The atmosphere at their breweries is really, really fun. So I would definitely have to give the nod to Great Notion, I think. What about you?
Yeah, well, speaking of Great Notion, on your recommendation, I took a friend and colleague of mine there right before the lockdown happened, in fact. So we got lucky there, and it was great beer. Really like that, but really impressed by the food they have there too, and the food choice. And I can't even remember what I got. I just remembered it was a great experience. So yeah, thanks for that. But my go-to spot, I'd have to say, it's near where I live in Southwest Portland. It's called the Old Market Pub. And this actually used to be an old grocery store, and they converted it to this really cool, just casual brew pub. They brew their own beer there. It's really good beer, but everything's picnic benches, and they've got all the games, the shuffle puck and pinball and all the bar stuff. It's just a really fun, casual atmosphere. Great place to go watch a game. So in the fall, when fingers crossed, college football season starts up again, that's going to be a spot to go hang out and watch some football or whatever your sport of choice is, because they got TVs all over the place there, and there's outdoor seating and everything. So it's a great summertime place to hang. So I'm hoping they're listening. Maybe they'll give us a sponsorship. I don't know, or at least maybe just a free growler I could fill up. That would be awesome. But
Yeah, at this point, I would just like to be able to go out and have a pint out. So maybe
we'll
sooner than later.
yeah, so you and I will try them both out when things open up. All right, and we can
Yeah,
see which one's better. But
that sounds like a great idea. Yeah, and we have so many cool breweries in Portland that we really enjoy, and I'm sure there's tons and tons of breweries all around the world where we have listeners tuning in today. So if you guys wouldn't mind, leave your favorite brewery and the city that it's located in the comments section of our YouTube page. We'd love to kind of start a conversation that's a little bit different than most of the conversations that go on during a hydraulic modeling podcast, but we always love to hear recommendations from folks. Yeah. So.
Well, hey, beer is made with water, right?
True.
And we're water engineers, so there's a connection there. But yeah, I agree, Ben. Leave some comments what your favorite brew pub is, no matter where you're at in the world. And Ben and I get out and we do some traveling, teaching this course, and we're always looking for a good restaurant or brew pub where we end up in. And if you have any suggestions, or better yet, bring us out to your location, and you can take us yourself to your favorite brew pub, and then that'll make us very happy.
Plus, there's nothing more satisfying than after a long day of lecturing about HEC-RAS to go out and try a local brew. That's always a highlight of a trip like that. So
yeah, for sure, absolutely, yep.
Awesome. So, well, today we are going to jump into another discussion on RAS Mapper. But before we get into that, I just wanted to give a shout out to our sponsor today, which is our firm, Kleinschmidt Associates. So a big shout out to them. They've been the ones really active in sponsoring this effort and allowing us to do this and give you guys the really insightful, cool conversations that we've been able to have up to this point. So Kleinschmidt Associates is known throughout the industry as a firm that provides practical solutions to complex problems affecting energy, water, and the environment. You can learn more at kleinschmidtgroup.com. And I know we're on session, I believe, number 4 coming up here tomorrow in our online 1D, 2D HEC-RAS class. That's been going really, really well. That's been put on by Kleinschmidt. Chris and I have been teaching that class. We've had a really, really great time. And I think we're narrowing in on a date in the fall for another one of those 1D, 2D online classes. So keep an eye out for the finalization of those dates. And we'd love to have even more folks attend. I think we had almost 40 people sign up for this last class, which is awesome, but we'd love to have more in the future. So keep your eyes out for that announcement.
Yeah, and I think that date is pretty close to being firm, starting October 7th. So if you want to mark your calendars, October 7th, but definitely keep your eyes out open and looking out for the next announcement. We'll have it on the RAS Solution. We'll have it on LinkedIn, all the different social media. So just keep your eyes open for that.
Awesome. All right, well, let's dive into today's topic. What this is going to be our RAS Mapper Part 2 discussion. For those of you guys who missed it, last episode, episode 5, we talked about the RAS Mapper window, as well as building 1D and 2D models within RAS Mapper. And that was a really, really great in-depth conversation. We covered a lot of ground there. I think it'll give a lot of insight to folks that are maybe new to using RAS Mapper or want to take their RAS Mapper abilities to the next level. But today we're going to move away from kind of constructing a model and really dive into how to view results within RAS Mapper. And so to start today, I'll pass it on to Chris, who's going to talk about the different types of result maps in RAS Mapper.
Yeah, thanks, Ben. Let me get my screen up here, and you'll see I've got the main RAS window here. So just as a reminder, when you're ready to look at results, you're ready to go into RAS Mapper, you can get there by clicking this button right here. You can also go to GIS Tools and select RAS Mapper, and that's going to bring up RAS Mapper. Hopefully, it will show up. Oh, it was on a different screen. There we go. Okay, so here's RAS Mapper, and you can see here I've got a check mark next to results. That means I've got some results maps turned on. There's actually 3 different plans here, and I've got the third one checked. So we'll just work off of that. And if you expand that plan, those results, you'll see a copy of the geometry file. This is just in here for convenience so that you can have your geometry turn on with your results when you check this box right here. But by default, you get 3 automatic dynamic maps. You get a depth map, a velocity map, and a water surface elevation map. Now you can add more. You can add what are called static maps or stored maps, or you can add more dynamic maps if you'd like to. But let's take a look at the defaults really quick. The first one is the depth map. If I click on that, I've highlighted it, I've made it active, but I won't see it until I check the box. So I've checked the box, it's highlighted, that means it's the active layer. And there I can see my depth map. If I hover over, you can see, I actually see the numbers here, which is kind of nice. You can just point anywhere and get an actual depth value. But also notice over here, hiding behind me and Ben, is the scale. I'll make this a little bit smaller so you can see the scale. So there's a scale 0 to 15. That's the default scaling. Even if you don't have depths as deep as 15 feet or meters or whatever units you're working on, that's going to be the default. It may work well, it may not, but you can change that. And just like any layer in RAS Mapper, if you right click on the label, you get an option for layer properties. And in there, you can change the scaling. You can double click on here. This brings up another window. It allows you to change the min and max to redefine the range of your scaling. You can even add more values in there if you'd like to. I'm going to keep it the same, but I'll also show you this. We touched on this a little bit last week, but if you click this update per screen, it works the same for your output as well. And it's going to optimize the scaling for whatever values are in the view area that you have at the moment. So if I check that, notice the scaling changes to 13.1. That means the deepest depth I have in this model is 13.1 feet. And I can zoom in as well. Oops, let me use my wheel mouse to zoom in here. And you can see the scaling changes because it optimizes for every view. I'm actually going to go ahead and turn off the mesh for now because that's just making things a little bit messy. And you can do that just by checking that box or unchecking it, I guess. And so here you can clearly see the thowig of the channel and the floodplain areas where it's a little bit shallower in flow. There's a couple other default maps. In fact, the one that I like to go to very first after I run a model is the velocity map. The reason for that is this is how you're going to find a lot of your issues, problems, maybe instabilities. And there's a lot to cover with instability. So we're not going to get into detail on instabilities and how to fix those here, but I definitely encourage you to sign up for our online class or our in-person class where we get into a lot of detail on how to find and how to troubleshoot instabilities. But here you can clearly see the velocity magnitudes all throughout your reach. And again, the same thing applies here. If you've got update per screen, it's going to optimize your velocity plot. If I go into layer properties and I uncheck that, it's going to go to the default 0 to 15. And this is not a really interesting map, right? Everything's blue. It's hard to really see any changes in velocity. So a lot of times it's beneficial just to come right in here and do the update per screen.
Yeah, I'll add something too. When you're changing the actual scaling on either your depth or velocity, oftentimes that's really helpful because you can discretize different cutoffs. So for instance, if you want to see everything over a certain velocity or over a certain depth as one color and then everything outside of that is a different color, we do that oftentimes when we're doing hazard classifications or restoration or fish passage, habitat evaluation type of projects. Having that discrete cutoff at different areas is really nice to be able to have, and that's something that we use this for quite a bit as well.
Yeah, really good point, Ben. And so that just kind of underscores the versatility of this velocity plot too. And you see how the magnitudes change throughout. The red, the darker red obviously is faster. The blue color is slower. So you can clearly see where the fast places are, but we have this other really cool feature in RASMapper called velocity tracing or particle tracing. If you click on that button right here, it's going to turn on particle tracing. But if you have the max velocity turned on, you're going to get this message. And this, don't worry about this message. It's just telling you it can't plot the max velocity profile. You have to actually go to a real profile before you can see particle tracing. So I'm just going to advance and I'll get to something close to the maximum here, something like that. And then I'm going to turn on my particle tracing. And there you can see, I can actually see little light traces that show you the direction of flow, but they're also scaled to the magnitudes. So wherever it's higher velocity, those particle tracings go faster and they have longer tails to them as well. And you have complete control over the look of these particles or these tracers in here by going up to the velocity settings button up there. Let me pull this over onto this map. And you can change the speed, the density of those light traces, the width of the traces, and even how long they last before those lights burn out. First thing I do usually is I'll go to speed and see if I can improve the look of it there. And so there you can see the direction of flow, and you can see how it expands right here. If you want to add more light traces, you can do that with more density there. And this makes them a little bit thicker. I usually like to keep them thin because it's easier to distinguish that way. And then you can make them last longer too. So, but usually the first two are the two you want to play around with. And this is
Yeah.
really important too if you're doing a full momentum run where you can see eddy patterns and separation zones.
Yeah, that's what I was just going to talk about. Is this is I think the two most useful parts of this particular feature are showing results to clients, because it's something that's very easy for engineers and non-engineers alike to understand what's going on. And then the other thing is you can really appreciate the difference in results between diffusion wave and full momentum
Yes.
simulations. And again, that's something that if you want to learn more about, we talk about that in depth in our 1D, 2D RAS class. But there's some significant differences that are really highlighted when you're using
Hmm.
particle tracing, which is kind of
So,
cool.
so looking at this, Ben, I'll put you on the spot. What do you think it is? Full momentum or diffusion wave?
It looks like diffusion wave to me. I don't see
Me too.
any eddies, especially around some of those areas where there's some
Yeah.
contraction expansion issues. So this would definitely look like diffusion wave to me.
Yeah, I would expect to see a separation here and an eddy pattern
Mm-hmm.
um, swirling around right there, probably off of this, shedding off of this embankment or whatever this is sticking out here. You probably have eddy patterns there. And maybe even behind this island, you can get some
Mm-hmm.
eddy patterns as well. And since we don't see that, it's likely this is a diffusion wave run, and I'm pretty sure it is. But anyway, that's velocity tracing, and you can actually look at this at velocity tracing on any map that you have over here. I mean, I can turn it on for my depth map. I just have to highlight it, make it active, and oh, there's that message again. Let me advance one, and there's our velocity tracing there.
Mm-hmm.
Now, the third map that I haven't talked about yet is the water surface elevation map. And I think it's the most boring map, but it's also one of the most useful ones. The reason it's boring is because it usually looks like this, right? And you don't really see the Thalweg in there. You don't see the main channel in there. You don't see any velocity hotspots or anything. It is a good idea though to scale it, because in this particular example, we don't have any elevations down in the 0 range. And in fact, if you look at the color here, everything's up near 100. So again, if I go in here to layer properties, I can do this update per screen. I can get a much more useful picture, and you can see how the elevation changes as you go downstream. So it's a little bit more interesting here, but still I think the depth and velocity are much more interesting to look at. But again, this is a useful one because you can actually see what was computed. These are
Mm-hmm.
the water surface elevations that were computed. And if I zoom in really close, and let me turn on the mesh again. Notice here when I'm inside, it doesn't really change much, right? It changes a little bit, and that's because there's some interpolation going on. But that's because RAS computes one water surface elevation per cell. And so you don't get the same kind of detail that you would get in a depth map, because the depths are actually measured off of the terrain, which is much more has much more resolution. So
Mm-hmm. Yeah, the water surface map is, I'd say the depth and velocity are the most helpful for viewing just as themselves. But when the power of the water surface map really comes into play when you're looking at, for instance, profile lines, which we'll talk about here in just a second.
absolutely, absolutely, yeah. Ben's going to show you that here soon. But before I turn it back over to Ben to show you profile lines, I want to show you really quick how you can add in other maps. Maybe you're interested in something else besides the 3 defaults, or maybe you want to create what's called a static map. The way you add maps to your output is you right click on the plan. This is the plan, okay, the plan group. So if I right click on there, you'll see add new results map layer. Click on that, and that brings up this window. And here you can see all of the different maps that are available to you. And I'll be honest, I don't have experience with all of these, so I'm not quite sure what a lot of these do, like recession. I haven't really played with that yet, but a lot of these are pretty self-explanatory. You see the default ones up here: water surface elevation, velocity, depth. You can look at flow, but that's only for 1D cross sections. You can do an inundation boundary. This is one, though, I always encourage you to turn on, because this is part of your evaluation of results and troubleshooting, is to look at the Courant number, because you want to make sure your Courant numbers are not too high. In fact, if you look through the manual for a full momentum run, they suggest targeting Courant numbers of 1 or less, and certainly no more than a value of 2. For diffusion wave, you can get away with a little bit larger Courant numbers, but you always want to add this in, and it's really easy. You just click on Courant, and just add map. Now I've got a current map here. If I turn off my water surface elevation, now I can see my current numbers. Here I am hovering. These are very low, which is good. That's a good sign. But if I put this, let me zoom out here a little bit. Okay, and what you're going to want to do is you're going to want to get to kind of the maximum level where you're going to have the highest velocities and look for current numbers that are really high. You can see the scale goes to 2, but I think if I go to my layer properties again and update per screen, it'll be something less than that. Yeah, not much less, 1.9. So I've got some values that are approaching the maximum you'd want to see for full momentum. Now remember, this is a diffusion wave one, so it's probably okay. But if you do see some really high values here, some spikes in current number, hover around here and look for those. Those are areas you're going to want to fix. Now you can add other maps as well. And again, just right click on the plan group and go to add new results map. And you can see there's other ones. You can explore those. Some of these are pretty obscure. These are used for dam safety and consequence modeling quite often, depth times velocity. Shear stress might be important for restoration jobs. But let's say we're interested in a specific map, like a specific time period. We can add what's called a stored map or a static map. Let's say I want to get that for depth. Okay, I can pick any profile in my run here and make a stored map out of that. So let's say I'm interested in this one I'm looking at right here, but I want a stored map. So I just scroll down to 13 January 0900, click on that, and this is what I have been doing. These are the dynamic maps generate for current view. But if I want to store one on my computer so I can send it to somebody or I can bring it up on Google Earth, then I just need to click over here. And I'm going to make this one a raster. It's going to be a raster based on the terrain. Click add map. And now I've got a static map here. But notice, first of all, it's got this diskette here, this save diskette. And that means that it's a stored map. So when you see that diskette, that means it's a static or stored map. But if you have a red asterisk, that means there's something going on wrong with that particular layer. In this case, if I right click on it, notice there's a compute. And the reason we have the red asterisk is because it hasn't been computed yet. So I'm going to go ahead and compute that. It takes some time. So while it's doing that, I'm going to uncheck. Oh, that was pretty quick, actually. And here you can see I've got a static map. Now you can't animate this because this is only one particular time period. But what you can do is you can now, you can take that and you can go to there's a folder in your directory where you'll see that map stored as a raster, and you can send that to anybody. You can open it up to ArcGIS. You can bring it into Google Earth if you'd like to do that as well. Mm-hmm. So that's the static map. So two different kinds of map, dynamic and static. Dynamic, you're able to animate here, but they're not stored on your computer. They're not stored anywhere except in the HDF file as tables. Or you've got your static maps, and those will be stored on your computer, and you can send those to other people or bring them up in other applications besides HEC-RAS. Mm-hmm. So, Ben, you got any questions on that or comments, or
I was just going to point out a few more things. You did a great job covering that, Chris. One thing to note is a lot of times with folks, when they're adding the cron number, they want to add the maximum cron number. And that's one of the only maps that you can't actually add the max condition for. You can only add it as basically a live dynamic map. You don't have the option of viewing the maximum cron number at any time step, which can be a little bit frustrating for folks, but that's just something you have to work through. And it's good to know that when you're adding the map, so you don't spend too much time trying to figure out how to do that.
Yeah. And I don't know why that's the case. I mean, it seems like that could be offered, but yeah, you're right. It's disabled, those buttons, but all you got to do is just got to kind of toggle back and forth and just keep your eyes open. And that's, again, setting the scale to something that will alert you to any high cron numbers is always a good idea. So then you can zoom through and look for those deep red colors that mean high cron numbers. And
the other thing too that can be helpful for not only viewing the results, but also if you're recording a screenshot or a video, or if you're showing these results to somebody, is to use the play button as opposed to scrolling through yourself. Yeah. So if you scroll through to the beginning of the simulation, and Chris, you can show them that play animation button over there. that will play it time step by time step throughout your simulation, which can be nice. Now, the thing to note about that is, obviously, if you have very small time step, that's going to take a very, very long time to play through. In this case, looks like you have hour-long time steps, so that's something that's very easy to watch in a few seconds. But
Yeah.
a lot of times when you have a model that has time steps of, a minute or less, you're not going to want to use the play button feature because it could take a very long time to get through. You're probably going to want to drag through to find the
Right.
results you're looking for.
Yeah, and you can control the speed of it too. In this case, because the mapping output interval is so coarse, it does go pretty quick. And so you might want to come into this where it's got a little turtle here and make it, it's already as close to the rabbit as possible. So it's fast. So you can slow it down, move it towards the turtle. You can slow it down a little bit and then see if that's a better speed for us. Now, a lot of people, when I talk about this animation tool, Ben, they ask me, well, how do you record it? There's no recording button here anywhere. And that's correct. They don't have a built-in recording tool for HEC-RAS, but there are several applications out there that will do screen capture recording. The one I like to use a lot, because I have it and almost everybody has it. If you've got Microsoft Office, you have PowerPoint. And if you have PowerPoint, you can record this. In PowerPoint, there's actually a screen recording tool. So check that out. And that's a great, easy way to record your screen, your RAS output.
I have an easier way to record your screen.
Yeah.
I'll keep that as a tip and trick, and maybe I'll talk about it here in a second. But yeah, it's a pretty slick thing. So I only have one other thing, Chris, to add, and I'm just going to go ahead and do it on my screen if that's okay. Okay, and this is related to the stored map conversation that Chris was having. So hopefully everybody's able to see my screen. I have the same data set Chris was working with. So I'm going to look at our depth map here. I'm going to kind of extend this to a point when it's a little further along in the simulation. I'm going to turn off my geometry layer so those results are nice and clear. One thing that's really helpful is if you're adding a inundation boundary, obviously you have the ability to do that with the inundation boundary, and then you can choose a profile either at an inundation at a specific time or the maximum or minimum condition. And you can then, save that inundation boundary to the folder of your HEC-RAS results. But a lot of times what I know I find myself needing to do is to get inundation boundaries for different depths. And what I mean by that is you might want an inundation boundary that shows all the depths that are greater than half a foot, or all the depths that are greater than 3 feet or 5 feet or 1 foot, or wherever your cutoff is. And a lot of times we want to do this for hazard classification reasons. And there's a way you can do this that's pretty slick and not super known. So the way you can add an inundation boundary at a specified depth is if you click on your depth and you go to a profile, or again, your maximum condition. If you click on polygon boundary at value and specify the value that you want to create a inundation boundary map for. So for instance, I could create a depth map showing all of the depths that are greater than 1 foot. Okay, I'm going to go ahead and add this map in, and then you'll see here, it actually comes in as an inundation boundary, which is kind of weird. It's like, wait a second, we added a depth map at a specific contour of greater than 1 foot, but because it's really in reality an inundation map, it comes in as an inundation boundary with a value of 1. So this is going to show all of the areas that have depths of at least 1. So if I compute this map, it's going to go ahead and process. Like Chris said, sometimes these maps take a little bit of time to compute, especially if you have a really large data set with a lot of cells. We should get an inundation boundary that shows us that, which is pretty slick. So if I turn off the depth map, now you'll see we have an inundation boundary that actually shows, again, this is our depth, and I'm going to go ahead and turn on the maximum value here. And then this is our inundation boundary. So I'm going to move, you can order these maps too, which can be kind of nice. So if you right click on inundation boundary, move the layer to the top, now it'll display my inundation boundary actually on top of my depth boundary. And you can go through and you can actually zoom in here and see, like, okay, all of these depths are going to be less than 1 foot. versus my inundation boundary here that's been created is anything that's greater than 1 foot. So again, really helpful when it comes to hazard classifications or other type of results maps. If you're doing any type of rain on grid modeling, a lot of times you don't want to show every cell that has any water, because every cell has water at some point. So maybe you only want to show cells that have at least a tenth or a half a foot of depth in them to really get a good idea of what's actually flooded as opposed to what's getting rain on it. That's a really, really cool feature that I found helpful.
Yeah, good point. Just shows the extent of how you can use this, and I think Ben will agree with me that neither of us have really truly unlocked all the secrets of how you evaluate your data. I mean, there's so much in here you can look at, but this is a great one. Glad you showed that, Ben.
Yeah,
Really cool.
absolutely.
Cool
So
feature.
that was kind of building off the maps conversation that Chris had. And that's definitely the primary way that people view 2D results in RASMapper, is just through the dynamic or stored maps. It's very helpful. It's visually appealing. But there's another way to view results that can be really, really powerful and helpful when it comes to viewing the results of a 2D model, and that's using profile lines. So many folks who are familiar with 1D modeling are used to viewing results either via the profile plot within HEC-RAS or the cross-section viewer plot, and can see and being able to see water surface elevations at different cross-sections or different locations or along the river profile. Now in 2D, there's not a default way to do that. The way you have to view those results in that way is by drawing in profile lines. And you can draw in profile lines that are either along the profile or parallel to flow, or as a cross section that's perpendicular to flow. And both of those are going to provide different types of data. So I'm going to zoom into a couple profile lines that I've drawn here at the upper end of our model. And you can see that this is a bad, actually, I'm going to go ahead and refine this profile line because this isn't as accurate as I would like it to be. So I'm going to go ahead and delete that profile line. Again, the way you add a new profile line is right click on profile lines. I'm going to go ahead and stop editing, edit the layer. And then you have the option of either selecting an existing profile line or drawing a new one. So I'm going to draw a new one here that just kind of extends down the somewhat center line of my stream here, just to get an idea of what is my water surface doing as I move downstream. This would be the equivalent of a 1D profile plot. Now, obviously, you don't have to extend this thing down the entire 2D domain if you don't want to. I'm just going to go ahead and stop mine there. And then you're going to go ahead and stop and make sure that you save those profile lines. You can also draw profile lines from the dialog box here in the lower left-hand corner. I usually work in the feature profile lines, though. It's probably just more of a preference than anything else. Once you have this profile line drawn, the way you can view results is you're going to want to make sure that you have a result map turned on. So if I try to review the results right now, the only thing I could view is, if I go to plot profile, is the terrain, because that's the only layer that's on right now, which might be something that you want to look at. Maybe you're trying to identify what the slope of your river reach is or something like that. But most of the time, what you're going to want to do is make sure that you have a map on. So in this case, I have my maximum depth turned on. And what I'm going to do is I'm going to view the depth as I move downstream. So I have depth turned on. I'm going to go to plot profile. Now I have two options. You can see I can plot the depth along the profile or the terrain. So I'm going to go ahead and do the depth. And then this is the result that you get. So you can see that it varies a little bit, but ranges between 4 and about 7 meters in depth along here. Again, an unlimited number of applications or reasons why you might want to look at this. It's also very helpful. Again, water surface elevation is going to be key a lot of times when we're talking about using profile lines. So if I have water surface elevation on now, I make sure you're not able to select these profile lines unless your profile layer is actually selected. So make sure you have that selected. Right click, plot profile. Now I have a bunch of different options. Okay, so I'm going to go ahead and look at water surface elevation, and this is a really slick plot because it shows not only the channel thalweg elevation, which is represented here in brown based on the terrain, but also our water surface elevation. You can see the hydraulic gradient, and this looks virtually identical to what a 1D profile plot would look like. So that's really helpful. The other thing that's really nice is not only related to profile plots, but if you're going to do something perpendicular to flow that emulates something like a cross section, So here I have another profile line that's drawn just like a 1D cross section would be. And I want to go ahead and view, let's say, the depth across this cross section. Idea, and you can see, so it's very shallow or no depth on the outside, and then as we move towards the center of the channel, the depths are deeper. Really, what this is it's almost an upside down cross section. Looks like. Similarly, you could turn on your velocity map and see what are my velocities across this cross section. Am I getting one side having higher velocities than the other? You can see this is pretty uniform, which makes sense if we look at the channel. It's fairly straight. It's reasonable to assume that we have probably fairly uniform velocities across that channel. You can see that that's represented there. Another way that you can use profile lines to analyze results is to look at the results dynamically. So those were static maps. Again, we plot the profile of either depth, velocity, water surface elevation, or terrain. You can also plot a time series. So for instance, if I want to look at what is the flow moving across this cross section over time, you can right click, plot time series, and in this case, I'm going to look at flow. Okay, it's going to take a minute to generate, and then it's going to give you literally a flow hydrograph that's moving over that cross section, which is really, really nice. Similarly, you can look at volume accumulation across that curve. So if we do that, it's going to be obviously continuing to increase over time as the volume that moves across that line continues to increase.
What about the Ben? What about that that jagged line over the top of your cross section there?
Yeah, great question. I believe what that represents is our cell faces. So if I right click on here with the geometry on, I think everybody will be able to see that. So I got my flow hydrograph across those cross sections, and what it's doing is it's highlighting the cell faces that represent how that flow is moving across. So this flow hydrograph is, I believe, represented by how much flow is actually moving over these cross section faces. Is that correct, Chris?
Yeah, over the cell faces. So it's highlighting what cell faces RAS is summing up to get the total flow across that line. So you can imagine that it may not be perfectly accurate because that line is skewed to the faces. So if you want it, this is a good way to do a quick check on flow hydrographs just to get an idea of what the peak is. But if you really want to be exact here, you would put a break line right where that profile line is so that the cell faces line up to it, recompute it, and then look at it that way.
Yeah, so if you wanted to do that, you could do that very easily by right-clicking on your profile lines, editing that. Go ahead and copy that profile line. You just want that one. Control copy. Go into break lines, right-click, and then we're going to go ahead and stop editing this. Break. Oh, and that's the other thing is you can't edit the geometry in the results menu. You actually have to go up to the geometry layer itself. I'm going to come into 2D areas, break lines, right-click, edit. I'm going to come into tools, paste my feature. Okay. Now you can see we have a break line that's now in there, and we could go ahead and enforce this break line. Now we can see our cell faces line up along that break line now. So that would be much more accurate representation. So again, like Chris said, use those profile lines to get just a general idea of what's going on. And then if you really want to use those cross sections to maybe export the results to a report or something that's more permanent, make sure that you enforce those as break lines. It's a great call.
Yeah, you should show the water surface over that transect line, because that, you showed before how the longitudinal profile line is analogous to the water surface profile plot in 1D, but same thing for that transect line. If you turn on the water surface elevation and plot that, it's analogous to the cross-section plot for 1D. So you get yourself a nice little cross-section plot right there.
Yeah, so if I go to plot profile, water surface elevation, and so you can see that water surface elevation that's uniform across the channel. The other cool thing about this is right now we're viewing just a single time step, but you can also go up here, go select your water surface elevation and move this through time, and you'll actually see your water surface elevation in the lower left there changing as time moves on. So this is kind of a dynamic cross-section viewer map, similar to what you can do in 1D, which is really helpful. And you can do the same thing with the longitudinal line that goes through our channel profile. So again, here we have our water surface elevation. at a specific time. And then if we go ahead and select the result on the left and go ahead and drag that, we can see that water surface elevation actually change over time as the flood waters come through, and then eventually stuff starts to recede. So all really cool ways to utilize profile lines. Again, when you're kind of qualitatively viewing the results of your model, you're going to want to use just dynamic and stored maps. But when you really want to dig into the numbers, it's going to be really helpful to use profile lines. Now, if you're trying to extract information from individual points, let's say, or individual cells, you're also able to do that if you simply, for instance, go ahead and click on a cell here. I'm going to go ahead and have water surface elevation selected. I'm going to right click here, and you can plot a time series of water surface actually at that cell. Okay, and again, this is the water surface elevation that would be occurring during the simulation at that particular point that you can see highlighted here with this black dot. If you have a shapefile, a point shapefile that has actually a number of different points, you can also select those points individually and extract water surface velocity or depth data over time, or at a single time step from the results.
It's a great way to calibrate, right? If you've got high water marks or even gauge data out in your 2D area, you can click on the location of that high water mark or the gauge data and pull up that plot, and you can see how well you're doing from your calibration.
That's exactly what we're doing on a project right now where we're simulating a reservoir drawdown in Utah. And we have, I believe, 8 or 9 locations throughout the reservoir where we have piezometer or pressure gauge data. And we have those brought in as a shapefile, and we are extracting the results from those individual points to calibrate our model, which is pretty cool. If you want to, these are obviously profile lines. You can also bring in actual points. So for instance, you can create a new layer and a point layer, and then you could edit that point layer and copy in points from a shapefile or something else if you have that available, which is really, really slick. You can also just come in here, create a point layer. I'm going to call this points. Okay. And then you can edit this, and you can go ahead and add a new feature, and you can add a couple different points here. And then if you stop and save these, now you can come in here suddenly and you can extract the information at those individual points, which is kind of nice. So very dynamic, like Chris said. I feel like RASMapper is one of those things that every week I learn something new or a better way to do something. This is definitely something that is evolving through time, and I know that with the upcoming 5.1 release, there's going to be some even better ways to view results.
I was going to say it's going to feel like I'm a beginner again when 5.1 comes out with all of the new stuff they're going to have in RASMapper and elsewhere in the software itself.
Yeah,
a lot of cool stuff to come.
I know we talked about a couple of those things. They're going to have a really cool 3D viewer in RASMapper. You're going to have the ability to export results directly to a KML where you can bring it into Google Earth and view kind of areas that are underwater. So some really cool stuff coming up in 5.1. I'm sure we'll have a chance to highlight that. But yeah, again, that was our part 2 of our RASMapper series, viewing results. There's so much more information to be garnered from discussions related to viewing results. I think one of the things that Chris touched on just lightly, how to view results and use the results to calibrate your model, troubleshoot your model, figure out if your model is running smoothly, if it's having issues, if you need to change some things, because 2D modeling is a blessing and a curse. It's super easy to set up. It's super easy to run. It's very stable. But because of that, there's a lot of models out there that when you run them, don't look like you're having any issues. But if you really dive into results and you know what to look for, you're getting some really bad modeling results that if you used in an engineering setting or something like that could really put you at risk. So if you guys want to learn more about that, we really encourage you to take our 1D, 2D HEC-RAS class. We talk a lot about viewing results and leveraging RASMapper to help you troubleshoot a model. So please do that if you want to know more.
Yeah, absolutely. There's a lot to it. And unlike 1D modeling where, you usually are going to get some errors showing up in your computation window if there's some problems. If you get a model that runs all the way through and there are no errors that show up, usually as long as your input's good, that means you're going to have some pretty good output. But for 2D models, you can have a model that runs to completion, no errors, it looks really nice and clean, and then you go into RASMapper and it's out of control. You got all sorts of issues, and problem spots. And so usually that's a result of a bad current number, but there's some other things too. And so I agree with Ben. If you guys want to dive deeper into that, look into our online class. As we mentioned at the beginning.
Or an in-person class. If you're an engineering firm or a group of folks that are really interested in getting group training that's in person, reach out to us too, because hopefully sooner than later, Chris will be back on the road. Chris and I will be back out on the road doing some of these classes in person, and maybe even grabbing a pint from your guys' favorite local spot.
Yeah, especially if you got a really good brew pub where you live. Not a
Absolutely.
qualification though, but definitely a bonus.
Cool. All right, Chris. Well, the first two parts of our series, again, we covered the RAS mapper window, building 1D and 2D elements, viewing results. I think about the only thing we haven't touched on yet is related to mannings. And so I think that'll be one of the upcoming video blogs that we have here that we talk about mannings, both in a 2D setting, a 1D setting, override regions. There's a lot of cool stuff that we'll get into and definitely one of the upcoming episodes.
Yeah, that'll be a good one to do. So everyone stay tuned for that. Hopefully that'll come up really soon here.
Awesome. Well, Chris, before we dip out, is there anything else that you'd like to add to this discussion?
No, I think we covered, at least at a cursory level, everything you can do for both pre-processing and post-processing in RAS Mapper. So I hope this has helped everyone out. And with all this talk at the beginning of this podcast, I think I'm going to go out now and go to the Old Market Pub and get myself a growler.
As you should. So just a reminder to everybody, leave some comments in the YouTube chat here. Let us know about your favorite brewery in your local city and what city it's in. Leave us any questions that you might have related to this video. And please keep an eye out for that next online 1D, 2D class. Again, believe it's going to be October 7th. Keep an eye out for the announcement coming soon. And yeah, we're excited to dive into HEC-RAS more with you guys beyond just these fun 30 to 40 minute videos that we've been doing. So
you got it. Yeah.
All right. Well, with that, this has been Full Momentum, an HEC-RAS Vodcast.